So today we are going to look at a new area, and the new area is called functions. It's called functions. The topic is called functions, and when we talk about functions, we look at calculus, general. When we talk about calculus, we are talking of differentiation. We are talking of integration. And finally, there will be applications. Finally, there will be applications. Those are the areas that we shall look at in that topic of functions. So I've already given you the handout on the same. You can check in your WhatsApp groups or in your phones. That is what I would like us to go through. And then from there, as usual, we discuss what is in the notes. Then we start now computations one by one. So when we talk about a function, it is a mathematical expression of the relationship that is existing between variables. So a function is a mathematical expression of a relationship that exists between variables. And in any relationship, there are usually at least two parties. And the parties in the functions are called dependent and the independent. In the relationship, the independent one is the one that guides, it's the one that shows the direction. And the dependent is the one that follows. So when we're in the world of functions, the dependent variable is represented by letter y, while the independent variable is represented by letter x. Now, in any function, it is possible to have more than one values of x or more than one x's. But in a function, you can only have one dependent variable. You can only have one dependent variable. Now, when we are writing this relationship, it is usually written as y is equal to f of x. Now, when you write that, y is equal to f into brackets x, it is usually read as y is a function of x. Y is a function of x. And the meaning of that is that the values you see in y are brought about by the values in x. So the values of y depend on the values of x. But this is further expounded to be like y is equal to a plus bx, whereby now this y here is the dependent variable, x is the independent variable, and this value of a here, it is usually called the fixed or the constant because it represents the value of y that is not affected by x, the value of y that is not affected by x. Then we have this b. B is the slope. It is the value at which y changes when x changes by 1 unit. Then we have what we call types of functions, as you can see. And I want to say that calculus is also a very, very wide area. If you look at mathematics books, you'll find that they are very rich in calculus. Calculus is even a course you can pursue at the university level. So it is very, very wide. So when you talk about functions, we are talking of things that are very, very many. Now, in this case now, we have just a few functions that I would want to highlight that are in line with what we are supposed to do as accountants. So the first one is what we call logarithmic function. Now, a logarithmic function is a function that has a log as part of it. For example, when you're told y is equal to 3 log of x, that is a logarithmic function. Now, for our case here, I will not get into a lot of details about the logarithms, about the mantissa, the characteristics, the powers, and so on, because we already have a scientific calculator, and that scientific calculator is the one that we shall use to compute these values. The other thing is what you call univariate function. Now, a univariate function is a function which has only one independent variable. Like now, this one, this is a univariate function because there is only one independent variable. So a univariate function is a function that has only one independent variable. Then we have what we call multivariate function. Now, multivariate function are functions that have more than one independent variable. Functions that have more than one independent variables. For example, y is equals to a plus b1 x1 plus b2 x2 plus b3 x3, and it continues that. Now, that one is called multivariate because it has more than one independent variables. Then we have what we call exponential functions. Now, an exponential function is a function whose independent variable is part of the power. Is a function whose independent variable is part of the power. For example, y is equals to ex, ae raised to power bx. Now, the independent variable here, you can see it is part of the power. Now, these exponential functions, first of all, they used to be more applied in a topic we used to call queuing theory, but when they revised the syllabus the other day, they removed it. So we no longer teach you queuing theory. And for now, I don't want to get into a lot of details. I want to wait until we come to do something called exponential probability distribution, so that I show you how to get the values that you can see there, the KINA 2.718. If I show you right now, I know you will still forget and tutasumbuana when we come to that topic of probability. So that's why I'll keep it pending until we get there. I'll show you how to get those figures in the calc and how to proceed. Now, the other thing is what we call polynomial functions. A polynomial function is simply a function that has powers, a function that the values are raised. For example, we have a plus bx. Now, that is a polynomial function to the first order. But if you have b1 x1 raised to power 2, that is second order, and so on. So a polynomial function is a function whose independent variable is raised to a particular power. And that power is known as order. It's known as order, or is known as degree. So when you hear of the first order polynomial, it means a function whose x has been raised by 1. If you hear of third order polynomial, we are talking of a function whose x has been raised to power 3. The highest power is 3 in that function. So we have very many polynomial functions, but the most common, again, as you can see there, we have the first one, which we normally call linear functions. We're looking at them in details. The next one is what we call the quadratic functions. We're looking at them in details. The third one is what we call cubic. It's not indicated there. We'll also come across it. And then we have the nth order. The nth order, depending on how high n is. Now, from there, we have applications of functions in business areas where functions are used. One, they're used in computation of revenues, costs, profits, what we normally call CVP. You'll be seeing that most of the questions that we'll be handling, they will be talking about costs, they'll be talking about revenues, they'll be talking about profits, just like we saw in matrices the other day. The other thing is computation of wages. We are able to compute wages. We are able to analyze demand and supply. We are able to compute probabilities. There is computation of depreciation and appreciation of assets. There is setting of prices, determination of maximum and minimum values of variables, etc. So Functions are widely applicable in business, and that is how we use them. Now, from there, we go now to what we call linear functions. And linear function, we are told a function is said to be linear if it takes the form of y is equals to a plus bx. Other characteristics of linear functions are the highest degree is 1. So we are saying a function is called linear if it is of the form y is equals to a plus bx. That is what we call a linear function. And the other characters you notice is that the highest degree of x is 1, although we normally do not keep on writing. The next thing is that the function has no turning point. If you were to plot it on a graph, it will not show you a turning point. It will give you a straight line. And we shall be doing that in a while. Now, this function is predefined when one of the following items have been provided. One, you have been given coordinates of any 2 points along the line, or you have been given coordinates of any 1 point along the line in the gradient. So if those two have been provided, the function is well defined. Now the values provided are substituted into the general format to obtain the equation. So that is what we call linear functions. And at that juncture now, we are in a position to write. So let me first of all block this area that has a reflection. So in your notes, I expect you to write this. That is the topic, eh? Okay, then I think linear functions. Linear functions. Then you write illustration 1. Illustration 1, which reads, developed and brought the equation of a line passing, developed and brought the equation of a line passing through point A, 3, 7, and point B. So solution. So when you are dealing with linear functions, the first thing is to write the format. The format is y is equals to a plus b x. So you write that. That's the format. Y is equals to a plus bx. Then you now substitute these points. So if you start with point A, y is 7. A plus b, rather x is 3. So 3b. This is because of point A. I hope you remember that this one is always x and this one is always y. Yeah, the coordinates. Then coming here, this is 3, this is 13. We have A plus 5B. And that is because of point B. That is because of point B. Then from there, we subtract here. Subtract here. And when you subtract, 7 minus 13 is minus what? Minus 6. Is equal to 3 minus 5 is minus 2B. And therefore, B must be 3. So, B is 3. So if B is 3, then you come here and substitute that 7 is equals to A plus 3 times 3. So tell me A should be minus. A should be minus 2. So, and thus, the equation y is equals to minus 2 plus 3x. That is how you develop a linear function when you are given two coordinates. If you are told to plot, you look at the values of y. The values of y, they are these two. This 7 and this 13. So the highest is what? 13. And the values of x, there are 3 of them. The values of x are usually 3. There is this one, and this one. So the lowest is minus 2. So let's just sketch something small. Just sketching something small. So if this is 2, this is 4, this is 6, this is 8, this is 10, this is 12, this is 14. Y-axis, this is minus 2, this is minus 1, this is 1, 2, 3, 4, 5, 6, 7. Just like a small graph. This is x-axis. That is x-axis. So when you get A, it is 3, 7. So my 7 is somewhere here. So my 3 is here. This is where my 7 is. So 3, 7. This is point A. And 5, 13. So my 13 is here at 50. This is point B. So you mark the when, then connect them. Connect them with a very straight line. That way. A very straight line. Y is equals to minus 2 plus 3x. And you can see it's supposed to be on the negative. The line has not come out well. It's supposed to be the value of y, negative 2. Let me try. The line has not come out well. Brought here. 2 is 7. 7 is here. Brought in 3, 7. 5 13. Oh, 5 13. Which was 7. Which was 7. So these are the values of y, the intercept here, and points A and B. Yeah, see, that is okay. Yeah, so that is how you're supposed to plot and come up with the equation. So illustration 2. Illustration 2. And we can develop and plot the equation. Develop and plot the equation of a line passing through point A to 6. So I would like you to leave a small space, like what the first question had taken, utajaza baadaye on that, and then we go to illustration 3. We go to illustration 3. Illustration 3, which you read like this. Develop an equation of a line whose gradient is 10, whose gradient is 10, and passes through point A 2030 passing through point A, 2030. So we come here and get the solution. Get the solution. The solution, you say y is equals to a plus bx. Y is equals to a plus bx. So again, you substitute those values and say that the value of y here is 30, a is unknown, b is unknown, but x we know is 20. So 20 times 10. So from there, we get this is 200. So a must be minus 170. So negative 170. So thus, y is negative 170 plus 10x. Okay, then from there, illustration 4. Illustration 4. Develop an equation of a line whose gradient is -6. -6, and pass it through point A minus 18 and 42. Develop that quickly for the answer. So what is the answer? Negative. Y is negative 66, eh?
It's minus 6x.
Minus 6x. Agree? Okay. So Tracy, are you in agreement?
Yes.
So if that is agreed, then we are through with the linear functions. Let us proceed to quadratic functions. Quadratic functions. Now, a quadratic function, if first of all we refer to the characters that have been given in the notes, you find that it is a function whose format is y is equals to ax squared plus bx plus c. That's the function. That is the format of a quadratic function. The characters that you notice with the quadratic equations are: number one, the highest degree is equals to 2. Number two, there is just one turning point. If you are to plot it, you just get one turning point, or what we call a point of inflection. Number three, the equation has two solutions or two roots, which can either be real or non-real. Real is when b square is greater than 4ac, the quadrant, or non-real is when it is less. Although for your case, you may not come across the non-real, but if you do mathematics at the university level, you may come across this. We call it the de Moivre's theorem. The solutions can either be obtained using the quadratic formula, as you can see there, or we can use what we call a graph. So I want us to have an example. So I think I have this one. Now this illustration one, I'm going to use some figures that are in the question of June 2013, question 1B, but don't open the question because you're not going to read. I just want to take the figures. Time to read the question will come. So in that question, we are given computers sold which are our X, and then we have sales revenue, which is our R. Here we have 10, and this is 1650. Here we have 25, and this is 3375. And then here we have 40, and the revenue is 4,200. So copy that. So if you are given data like that, if you are told to develop a quadratic function for the revenue, you are told to develop a quadratic function for the revenue. So in the solution to that, we have said that a quadratic function is fully defined when you are given 3 coordinates. You can see those are real values. So you start with the format. So the format here we shall use R is equals to ax squared plus bx plus c. That's the format. Although in the notes I've given you y, but this one you can use any data depending on what you're dealing with. The most important is that here the highest power of x should be squared. Then we have 1, and then we don't have x here. So when you have put it that way, you now start substituting. So unakuja unaweka hii 1650 So 1650 equals to 10 squared. 10 squared is 100. So 100A plus 10B plus C. And that one you call it equation number 1. Call it number 1. Then we go to the next one, that 375 is equals to 25. 25 squared is what? 625. So 625A plus 25B plus C. That is equation number 2. That is equation number 2. Then we have the third one, 4200, which is equals to 40. 40 squared is 1600. So 1600A plus 40B plus C. That is equation number 3. That is equation number 3. So when you have simultaneous equations that way, you can solve using matrices like you are doing the other day, or you can use elimination. And what to use elimination? When you're using elimination, of these 3, you look at the one that is easier to remove. And the one that is easier to remove is the one whose coefficients are already equal. The coefficients are already equal. You can see the C, they are 1, 1. So that is the easiest. So we will say removing C from equations 1 and 2. Removing C from equations 1 and 2. I'm going to have 1650 here being equal to 100A plus 10B plus C. That 375 is equal to 625A plus 25B plus C. Now, to remove them, you just subtract. Remove C, you subtract. So when you say subtract, 1650 minus that 375, you get what? Negative 1725. 100 minus 625. Negative 525E. 10 minus 25. Negative 15B. And this one you call it equation number 4. You call it equation number 4. When you call it number 4, you proceed and say removing C from equations 2 and 3. From equations 2 and 3, we come here and say that 375 is equal to 625A plus 25B plus C. Then 4200 equals 1600A plus 40B plus C. So you subtract. Negative 825 equals Negative 975A. Negative 15B, yeah? And this one you call it equation number 5. Call it equation number 5. So when you call it equation number 5, you proceed and say, removing B from equations 4 and 5. Equations 4 and 5. Equations 4 and 5. You take this one minus 1725 equals minus 525A minus 15B. Then 825 equals minus 975A minus 15B. So here what you need to do is to add, no, not to add, it's also to subtract. It's to subtract also, so that B can disappear. So minus 1725 minus 825, what do you get? Minus 500. 900 minus 900 equals the next one. Minus 525 minus 975, you get 450A. So 450A. So then A should be equal to -2. So if A is -2, you proceed and say substituting in equation 5. Equation 5. You will have minus 825 is equals to minus 975 times -2. That way, you minus 15B. So this becomes 15B is equals to 975 times 2 plus 825. So from there, tell me B will be equal to what? One into 5. Okay.
The question, I think you need to keep it as the cells are like you know the R and X, are they going to believe that R and X?
Not a must. Not a must that they put to you that this is R and this is X. You should know. By what I said in the relationship, we have the dependent variable and the independent variable. Independent variable is the one that makes the other one to change. So between computers and revenues, which one makes the other one to change? The computers. So if it's the computer, that becomes your X. So it's not all the times you'll be told. Okay, so remember this is what? 185. So if it is 185, then we come and say substituting in equation 1. Substituting in equation 1. Equation 1 is going to be 1650 equals 100A. So 100 times minus 2 plus 10B. So 10 times 185 plus C. Plus C. So from there, tell me the value of C is what? C is 0. Yeah, C is 0. So if C is 0, if C is 0, you tell us hence R is equals to minus 2x squared plus 185 plus 0. So that is the quadratic function. Let's look at another illustration. Illustration 2. I want to use some data I'm extracting from April 2022. Question 1A. So here we are just given units and the costs. So the units are 4 here. Cost is 10,404. Then we have 8. The cost is 98.2. The cost is 12. Other units are 12. 92.72. So solution. So once again, we will say our total cost is ax squared plus bx plus c plus c. Sasa, you take the first one here, 10,404 equals 4 squared is what? 16. So 16a plus 4b plus c, and that one you call it equation number 1. 98.2. is equals to 8. 8 square is what? 64a plus 8b plus c. That is equation number 2. Haya, huyo mwingine 9272. 12 squared is what? 144 plus 12b plus c. That is equation number 3. Haya, so removing c. Removing c from equations 1 and 2. Removing c from equations 1 and 2, we have 10,404 is equals to 16a plus 4b plus c. 98 that 2 equals 64a plus 8b plus c. Minus, that gives you what? 572 equals negative 48 a minus 4b. That is equation number 4. Then removing c from equations 2 and 3. Equations 2 and 3, we have 98 that 2 equals 64a plus 8b plus c. 9272 equals 144a plus 12b plus c. $560 equals negative 8a minus 4b. That is equation number 5. So then we say removing b from equations 4 and 5. We have 572 equals minus 48a minus 4b. 560 equals minus 8a minus 4b. So again, we say subtract. This is 8. Is it 8? Huh? It is 12, yes, 12. And this one, this other one? That's 2. So from there, tell me A is what? 0.375. So substituting in equation 5, we have 560 is equals to minus 80 times 0.375 minus 4b. So 4b should be minus 80 times 0.375 minus 560. Negative 132. Point 5. Agree? And 47.5. Then redo so that you both confirm. Tracy, what do you have?
Negative 147.5.
Yeah. So it's negative 147.5. So if that be the case, then substituting in equation 1. Substituting in equation 1, going to have 10,404 being equal to 16,8. So 16 times 0.375 minus B. B is 147.5 times 4 plus C. Plus C. So solve and tell me C is what? It's taking too long to get C. 110, 958. 10, 988. Confirmed? Okay, so you tell us hence total cost should be 0.375x squared minus 147.5x plus 10,988. So that is the fixed cost. And the fixed cost. Now, illustration 3, still the same question, but now this one is revenue of 2320, 4480, 6480. Sasa, I want you to allow space like what the others are taking. Make sure you do that question because maybe tomorrow or the lesson after, we will require those answers as we do the applications. So allow space like the other one has taken. Like the other one has taken. So from there, I want us to write something called laws of indices. Rules of indices. So this one I'm just reminding you. One, if you are given a number like that, is that number raised to power 1. Number 2, you are given a number raised to power 0, that number is equals to 1. Number 3, you are given 1 out of that number, is that number raised to power minus 1. Number 3 or number 4, if you are given a raised to power m multiplied by a raised to power n, it is a m plus n. And finally, if you are given a raised to power m divided by a raised to power n, it is a m minus n. So those rules will come in handy as you go by divide. As you go by divide. So after that now, I think a differentiation. 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 So as you can see in your notes, differentiation is a technique in calculus we use to determine the rate of change. That is the gradient for nonlinear functions. And it is usually denoted by dy dx. So when we talk of differentiation, we are talking of dy dx, change in y over change in x. And when a function has been differentiated, it is called differential or derivative. It's called differential or derivative. Now, a function is differentiated with respect to the independent variable. So we have what we call the constant rule, the rules that we use in differentiation. So I'm going to highlight, maybe we may not highlight all of them, but if we are, they are good. So the first one, number one is called constant rule. Constant rule. Now, according to the constant rule, the differential of a constant is always 0. So utaandika constant rule alafu andike y is equals to 8, dy dx is 0. Andika tu hivyo. The differential of a constant is always 0. Differential of a constant is always 0. The next one is general. It's called general stroke power rule. General stroke power rule. Now this one is usually stated like this: if y is equals to ax raised power n, y is equals to ax raised power n, dy dx, there are two steps that we take. The first thing, you take this power, you multiply the whole equation by the power. So you take n here, you multiply ax, that's the first step. You multiply the whole function by the original power. Then you less 1. Then you less 1. So that is the rule. So, if you are given an example, example one, y is equals to 8. You are told y is equals to 8. Now remember, this is the same thing as 8x raised power 0. You are told y is equals to 8. The same as 8x raised power 0, going by the rules of indices. So, dy dx. You take the original power 0, then you multiply the whole equation by that. As the first step, you take the original power, then you less 1. Now we know any number multiplied by 0 is always equal to what? 0. Any number multiplied by 0 is always 0. If you are given example 2, example number 2, and you are told y is equals to 1 out of 7. Y is equals to 1 out of 7. Now, remember, this is I should have put this is y is equals to 7 raised power minus 1. 7 raised power minus 1. And this is the same thing as 7 raised power minus 1 x raised power 0. Because there is no x. So when you take the power here, dy dx, you take the power of x, which is 0, multiply this 7 raised power minus 1, and the answer becomes what? 0, because there was no x in that equation. Example 3. Example 3. If you are given y is equals to x raised power 7, y is equals to x raised to power 7. Then dy dx, will be, you take this power 7, x, you raise power 7, then you subtract what? 1. So this becomes 7x raised power 6. If I give you example 4, and you are told y is equals to 5x cubed. 5x cubed. Then dy dx, you take the power, which is 3, 5x raised to power 3, you minus 1, and this gives you 15x raised to power 2. Yeah. So that is the general rule. Very, very simple and very, very important. That is the rule that you shall be using almost everywhere in your topic of calculus. That general rule is very, very important. Number 3 is what we call addition and subtraction rule. Addition and subtraction rule. Addition and subtraction rule. This one is usually stated that if y is equals to u plus v, then dy dx is equal to du dx plus dv dx. Actually, we can put minus here, plus minus, so because we are combining plus minus. This one is very simple. So if you are told, example 1, y is equals to x raised to power 5 plus 10x minus 16 minus 16. Maybe let me make this square so that I'm left with 16x, and then I get 25 there. If you're given an equation like that, which has plus minus, the meaning of this is that you just differentiate each on its own, and then you add or subtract appropriately. So dy dx will be this one. Now, we take y on its own, power on its own, 5, then x raised to power 5, then you minus 1, that way, its own. Then ukuja hapa, useme 2, that is the power, then x, 2, you less 1, then you say minus. Now this is 1, 16x, 1 you minus 1 there. Then this one, remember it is 25x raised to power 0. So you minus 1 there, actually. So when you simplify this, nabaki na 5x raised to power 4 plus 20x minus 16. Because the other one becomes 0, right? Yeah. It is very, very simple like that. Very simple. Number 4 is what we call the product of the multiplication rule or multiplication rule. Now in this one, we normally say if y is equals to uv, y is equals to uv, dy dx, dy dx is udv, udv dx plus v du dx. V du dx. So example, I'm only going to give you an example here, because the first three are the ones that are very, very important syllabus. Just to mention. So if you are told y is equals to 8x cubed plus 16, multiply 5x squared plus 4x. You're given two functions like that. In the solution, you say let u to be 8x cubed plus 16. This one you call it u. That one you call it u. B to be 5x squared plus 4x, such that u dx, if you differentiate this now, this one, with respect to x, I believe now to be you consider. So it just multiply here, you divide 24x, I subtract, we achieve it square, 24x squared. Then you put up a dv dx, 2 times 5, that is 10x plus 4. dy dx, according to our formula here, you take u is this one, 8x cubed. 8x cubed plus 16 multiplied by dv dx. dv dx is 10x plus 4. 10x plus 4. Plus v. Our v is 5x squared plus 4x. You multiply by du dx. du dx is 24x squared. 24x squared. So that is how you handle the multiplication rule. Let's now handle the division rule. So in the division rule, we normally say if y is equals to u out of v, dy dx, is equal to v du dx minus u dv dx, you divide by v squared. Divide by v squared. So in the example, if y is equals to x raised to power 10 minus 5x cubed, you divide by 12x squared minus 4x. Kama umepewa hivyo, simply come here and say let u to be x raised power 10 minus 5x cubed and b to be 12x squared minus 4x, such that u dx is you differentiate this and get 10x raised power 9 minus 15x squared, and dv dx is 24x minus 4. Then dy dx, according to our formula there, you take p. P is 12x squared minus 4x multiplied by du dx. Du dx is this one, 10x raised power 9 minus 15x squared. Then you say minus u. U is 10x, sorry, is x raised power 10. X raised power 10 minus 5x cubed multiplied by dv dx. dv dx is 24x minus 4. Now the whole of this you divide by vx squared. So this is 12x squared minus 4x. Now that one is squared. The next one that we need to be familiar with is called logarithmic rule. Logarithmic rule. So in the logarithmic rule, we say if y is equals to a log of f of x, log of f of x, dy dx will be equal to a, the differential of that function, you divide by that function. Divide by that function. So, for example, if you are given y is equals to log of 3x, y is equals to 3x. dy dx, what you do, you take a is 1, so there is not right. You differentiate that function, the one after the log. So this one, when you differentiate in a baki 3, then you divide by that function 3x. This one, when I make apostrophe, means you differentiate. were to be given another example, y is equals to 17 log of 8 cubed minus 12x plus 3. We are given something like that. So dy dx, you take this 17 here, then differentiate this function, the one after the log. So this will be 24x squared minus 12. Then the whole of this you divide by that function, 8x cubed minus 12x plus 3. The last one is called exponential rule. Number 7, exponential rule. In the exponential rule, y is equals to a f of x, and dy dx will be equal to f of x differentiated a e f of x. That way. So, example, we are told y is equals to 16 e raised to power 10x cubed minus 5x squared plus 4x plus 19. If you are given something like that. So dy dx, you first take this one, differentiate it, that part, differentiate it. So when I differentiate, this will give me 30x squared minus 10x plus 4. Now this one, you multiply by 16 e raised to power 10x cubed minus 5x squared plus 4x plus 19. We'll leave it that way. The thing that I want us to discuss today is called higher order differential. Higher order differential. Higher order differential. We normally refer to them as HODs. Now, when we talk about higher order differentials, we are simply referring to a function that has been differentiated more than once. That has been differentiated more than once. So if you take a function here, illustration. So the function is y is equals to x raised to power 4 plus x cubed plus x squared plus x plus 12. You are told to get the first order differential. First order differential. You differentiate this for the first time. dy dx. It's going to be 4x cubed plus 3x squared plus 2x plus 1. That's what we call the first order differential, and the one that is gradient, and this is the one tutashinda tukiangalia, the one we shall keep on checking. Then there is what we call the second order differential. The second order differential. The second order differential. Now you differentiate b square y x square that way. So we are differentiating this function again. So this will become 12x squared plus 6x plus 2. Then, if you are told to do that order differential, so you differentiate that time x here, it's going to be 24x plus 6. You're told to do the fourth order differential. Differentiate for the fourth time y x raised to the power 4. This is 24. So this higher order differential, we use them to identify the turning points. As you can see in your notes, we have what we call the maximum turning point, and we have what we call the minimum turning point. When we come to the applications, this knowledge is very, very important. At what point we maximize, at what point we minimize. So we are going to call it a lesson at that point. But tomorrow when we meet, God willing, we shall start by looking at something we call partial differentials. Partial differentials. Partial differentials. I think we can add a grade. But I don't forget. There are 2 bits. I have not put them in my notes. So at times I usually forget. So partial differentials, they are great. So we will pick up from there in our next lesson.